Your poster looks at the effect of cell viability after cryopreservation. Is this a new issue within biopharma?
Cell therapy products have demonstrated incredible clinical promise, but they've only recently really received FDA approval and recognition as a commercialized product. With this short clinical history, almost everything about cell therapy development, manufacturing, and commercialization is actually new to biopharma. Without this long historical perspective, biopharma groups typically tend to use established and historical methods for their cell viability measurements. What our work clearly shows is that simple markers of membrane integrity, while they work for normal cultures, are not really valid for measuring cell viability following cryopreservation. And they should really be combined with additional measures of cell health, like we have here. Even those cells that actually do survive the cryopreservation process experience abnormal mitochondrial function and cellular redox balance that may negatively affect their function and render a dose ineffective when they're put back into the patient.
So Brian, was there anything that surprised you about the study?
Well, we were aware that cells experience delayed onset cell death and a lag in functionality after freezing. What we didn't anticipate was that these observed return to function could easily be diagnosed so early post-thaw. This is especially true with regards to the mitochondria. Here, pervasive mitochondrial dysfunction was evident almost immediately post-thaw, and it actually persisted for up to 48 hours in follow-up culture. So if this is verified in additional cell types, mitochondrial function indicators may prove to be a rapid and practical surrogate indicator of dose efficacy and during product development and in the clinic.
Your conclusions call for optimizing cryomedia. How can firms achieve this?
Well, the selection of an appropriate cryomedia is a very important way to present cryopreservation stress in commercialized cell therapy products. But it's not the only means to protect health, cell health after thaw. Cryomedia optimization is one component of what we term biopreservation best practices, which can be followed to standardize the transport, storage, and administration of cell therapies. If incorporated early into the developmental process, biopreservation best practices should allow for the efficient scale-up of the cell therapy from small batch size through large commercial scale manufacturing and commercialization. And they can essentially be used in all facilities, from academic centers to small biotech firms to big pharma.
Thanks, Brian. That's a very interesting topic. If PDA members want more information about it, what else can they expect?
Well, if anybody has any questions about specific parts of the poster, I'd be happy to answer email. If they have any questions, they can email me directly. I'm also going to be writing this up as an editorial in the PDA Letter that'll summarize this a little bit and make it easy that people can read at their leisure.